Open your book to page 93. Today's lesson is on translation of axes. The purpose of translating the axes is to make the equation more simple, make it easier to work with. And so, for example, this is how a translation works. So, for example, if you have let's say if I have a point right over here. So right now the point is 3, 1. So if we were to move the axis to here, so let's say if we move the axis to here. So originally this is your y-axis and this is your x-axis. So this point is 3, 1. Now if you move the axis to here, so this is your new y-axis and this is your new axis, then this point becomes 0, 0, right? And so now again, so everything based on the new axis is to make equation more simple to use. And the relationship between the two is in the book on page 94. In that blue box, you have x equal to x prime plus h. You got y equal to y prime plus k. So the x with this marking over here, this is a new x coordinate. This is a new y coordinate. Okay, but this is kind of harder to understand. It's better to do this way. So you got x minus h equal to x prime, y minus k equal to y prime. And this is more familiar. For example, if you have equation, the circle, that's your circle for example, you have x minus h squared plus y minus k squared equal to r squared, right? So this is when you have the original axis. Now let's say if you move the center to hk, then the new equation becomes x prime squared plus y prime squared equal to r squared. So again, so you see that? So whatever you see, the y minus k becomes y prime. See that? And x minus h becomes x prime. That's that. So again, you're already familiar with this form already. So all you do is just change that into the x prime, change this into y prime, and the equation becomes much easier to deal with. So let's go over some examples. Let's go to example 1. So example 1, it says find the new coordinate of point. So you got point 4, -2. So that's your x and the y. So you're looking for the new coordinate. So you're looking for x prime, y prime. If the origin is moved, so origin is moved to -2, 3. So new origin is your h and k. Okay. So again, just based on what we have up here, again, see x minus h is x prime, y minus k is y prime, right? So all you have to do is, so you're going to get the x. So you can write down the formula first. X minus h equal to x prime, y minus k equal to y prime. Again, you're more familiar with this format. So you're going to get 4 minus -2 equal to x prime, and so 6 equal to x prime. And so you're going to get y is -2 minus k is 3. So that's going to put all this in here, equal to y prime. So you got -5 equal to y prime. So your new coordinate, your new point, the coordinate of the new point would becomes 6, -5. And again, you can see from here, right? So this is your original point, right? It's 4, -2. Now when you move the origin from here to -2, 3, now this point, based on the blue, the new axis, right? It becomes 1, 2, 3, 4, 5, 6, and it's -1, 2, 3, 4, 5, right? So this point becomes 6, -5, and then that's what we have, right? So again, this is based on the blue axis. So maybe I should do the the blue. So again, this coordinate is based on the blue axis. So that's how you find a new coordinate. Now this example is not as obvious, to the advantage of this. But let's go to example 2. You can see the more advantage of this. So on page 95, example 2, you have the x squared plus y squared minus 6x plus 4y minus 3 equal to 0. Now the book method is a little bit harder to do. It's more complicated. They want you to substitute first. Okay, so what they did is they make x equal to, because over here, right, they use the book equation. So you got x equal to x prime plus 3, because they want you to move the point, the 3, negative 2. Okay, that's your h and k. So in this case, you have to simplify, you have to substitute. So you have to make this into x prime plus 3 squared plus y prime minus 2 squared, and do all that. And again, it's messy, so you don't want to do that. Okay, that's not a very good method. So best method is go ahead and complete the square first, and then you substitute. It'll be a lot easier to do. Okay, because the reason for that is because you're more familiar with both technique already, by complete a square first and also by substitution. Okay, instead of doing this, because this is kind of unfamiliar and it's more complicated. So let's go and complete a square first. So plus 3 on both sides, plus 3 on both sides. So get your perfect square, perfect square. So this would be x minus 3. So it would be plus 9, so plus 9. This would be y plus 2. So it would be plus 4, so plus 4. So this becomes 16. So now you substitute, right? So notice this is the h. So this becomes the new x. So I'm going to use different color to represent the new x. So this becomes the new x. So this becomes x squared plus, this is the new y, right? Because if you substitute, so it becomes y squared equal to 16. And that's your new equation. This is your original equation. Again, it's kind of messy. This is much simpler equation, right? Now, if you don't see how I get from here to here, right? Again, just substitute, right? Okay, so x minus 3. So again, if you see that, if you look over here, see the x prime is x minus h. Okay, and so that's that. Okay, now let's go to example 3. Okay, let's go to example 3. Example 3 is the same thing. You have the x squared plus y squared plus 6x minus 10y plus 12 equal to 0. And you want to translate the axis so that no first degree term, means you want to get rid of that. Okay, again, to get rid of that, you want to do same as what you do over here. Okay, so you need to complete a square. It's much easier to do. So you got x squared plus 6x. Oh, that's minus 12 on both sides first, plus y squared minus 10y equal to negative 12, right? So get your perfect square, get your perfect square. So this would be x plus 3, and so again, from this you get this, from this you get that, and from this you get plus 9, right? So same thing over here, this you get this, from this you get minus 5, from this you get plus 25, so plus 25. And so from here, you're going to get, let's see, 13, 22. Okay? So in order to get rid of this, you have to get rid of these. So that means you want to make this into, again, so this becomes x squared plus y squared equal to 22. And the part that you need to move to is, you're going to take the opposite, right? So from here, you need to move the origin. The point that you need to move to would be negative 3. Right? You have to take the opposite, right? And the 5. Right? Again, just think about the vertex or the center. Depends on what kind of equation, right? And so this is the point so this is your new origin. Okay, so if you move the origin to here, then your equation becomes this. Okay, and that's it. Now let's go and do some examples. So let's go and do number 2. So page 96, number 2. So you got 3, 2, 3, -2, and -3, -2, and -3, 2, and the new origin is 4, 1. So this is your h and k. Okay, that's your h and k. So that's your x and the y. So again, remember, x minus h equal to the x prime, right? And y minus k equal to the y prime. Again, this is easy to memorize. So the new point, would be, so this is the new point now. Okay. So the new point would be x minus that, so it would be 3 minus 4, give you a -1, and 2 minus 1 will give you 1. So that's the first one here, right? So this one, again, so I can use this formula, x minus h, right? So that's your, again, this your x and the y, right? So 3 minus 4 give you a -1. -2 minus 1 will give you a -3. Okay? And again, next one, x and the y, again, this point, right? So x minus h will give you a -7. Right? Y minus k give you a -3. Okay? And this one over here, x minus h give you a -7. Y minus k give you 1. So these 4 points become these 4 points. Okay, just using this formula. Again, this is much easier to use compared to the formula in the book. And also, you're more familiar with this, right? You see this a lot, okay, when you're dealing with the conic section equations.